Hello, let's solve some systems using elimination. You remember the last time we talked about solving systems of equations? And we gave you two different methods last time. Okay, first one was graphing. And you just find the intersection, or you find out whether the graphs are on top of each other or not. The second one was substitution. Okay. If you recall, you solve for one variable, then you substitute that value into the other equation and solve for the variable that's left over. Well, today we're going to talk about this third method, and there is one more method we'll talk about, but this is elimination. And what we're going to do is we're going to combine the two equations and eliminate one of the variables. And I'll show you what I mean by that. Suppose we have an equation here, 6x plus 7y equals negative 15. And we have another equation, negative 3x plus y equals negative 6. Well, if I multiply this bottom one by 2, look what happens. 2 times negative 3x is a negative 6x. Okay? 2 times positive y is positive 2y. And 2 times negative 6 is negative 12. Now, if I just bring this other equation over here, and it looks exactly the same, then I can combine these two. By combine, I mean add or subtract, whichever makes the most sense. In this case, I'm going to add. 6x plus a negative 6x is 0x. Cancel each other out, don't they? That's the whole idea. That's why we call this elimination. I just eliminated one of the variables. 7y plus 2y is 9y. And negative 15 and a negative 12 make a negative 27. So this makes it really simple to solve for y is negative 3. And so now I take that solution over to, let's say, make it this one. I say negative 3x plus y is equal to a negative 3. I can see that. Negative 3 equals negative 6. So negative 3x minus 3 equals negative 6. Add 3, negative 3x equals negative 3, because negative 6 plus 3 is negative 3. So x, of course, equals a positive 1. Divide both sides by negative 3, you get a positive 1. So now I say my solution is 1 and negative 3. I think that's the solution to my system. Okay? So what does that mean? That means, well, 6 times 1 is 6, plus negative 3 times 7 is negative 21. So the 6 plus negative 21, does that equal negative 15? And yeah, it doesn't take rocket science here. We know that 21 minus 6 is 15. This one's negative, so it's a negative 15. Now look at the other equation. Negative 3 times 1 is that's negative 3 plus negative 3. Well, does that equal negative 6? Well, of course it does. So we have, this is a solution. We checked it in both equations. It works in both equations. In other words, it makes both equations true. So we're done. Let's try another one. This time we've got 6x minus 2y equals 9. 6x minus 2y equals 7. This time, and you know, some of you probably already figured out what's going on here. We got a little 6x minus 2y is the same. So this time I'm going to subtract the bottom one. I don't have to change anything. I've got the same terms here. So 6x minus 6x is 0. Negative 2y minus a negative 2y, that's a negative 2y plus 2y, that's a 0. And 9 minus 7 is 2. Now the question is, see, remember when we solve, we want to find values, a combination of values for x and y. In other words, an ordered pair, x and y, that will make both of these statements true. Now, if I combine these statements, I get 0 equal to 2. Now, are there any values for x and y that will make 0 equal to 2? Is there any way in the world that I can ever possibly make 0 equal to 2? The answer is no, of course not. So this has no solution. This is one of those things where you have parallel lines, and if you change each one of these into slope-intercept form, you'll find that they have the exact same slope, but they have different y-intercepts. So this is no solution. And so let's try one more. Different color this time. I'm getting tired of the same color all the time. 8x plus 4y equals negative 16. 2x plus y equals negative 4. Now, watch what I do here. I'm going to multiply this whole thing by 4. 4 times 2x is 8x. 4 times y is 4y. 4 times negative 4 is negative 16. And look at the top equation. Look at this equation. It's the exact same equation, isn't it? So you know what that means. That means that we have a system that is the one line is over top of the other line, and we call this consistent dependent. And so what this means is there are an infinite number of solutions. Okay? Infinite solutions. Because every combination of x and y, every combination of x and y that's going to make this a true statement, and remember, there are an infinite number of combinations of x and y that make up this line. Okay? If we graph this, it's a line. And so there are an infinite number of x and y ordered pairs that solve this, that are on that line. In other words, they solve this equation, make this equation a true statement. And so since it's both pretty much the same equation, then we have infinite solutions. And we'll try another one. And this one is 3x minus 4y equals 3, and 2x plus y equals negative 5. When you're trying to figure out what am I going to do, what do I multiply by? This is a question students always ask. How do I know what to multiply by, and what do I do? Well, you look at 2 and 3. I don't see any common factors there, do you? But I look at negative 4y and 1y, and I notice if I multiply this by 4, okay, I'm going to have 4 times y. It's 4y. Negative 4y and a positive 4y will eliminate that. Remember, the name of the game here is elimination. Okay? What I'm looking to do is eliminate one of my terms. So I'm just going to keep this first one the way it is, 3x minus 4y equals 3. And the next one I'm going to multiply by 4. And that is 4 times 2x is 8x. Okay? 4 times y is plus 4y. And 4 times negative 5 is negative 20. This is one that's going to get ugly because you guys don't like this stuff when I get fractions, but watch. 8 and 3 is 11x. These two, negative 4y and positive 4y, eliminate each other. And so that equals negative 20 plus 3 is a negative 17. So if we divide both sides by 11, I have x equals a negative 17 over 11. Eek, says the student. I can't do fractions. Yes, you can. Watch. 2 times a negative 17 over 11. That's this right here. Okay. Plus y equals negative 5. So 2 times a negative 17 is a negative 34 over 11 plus y equals negative 5. But if I want to change this to 11ths, I just multiply the numerator and the denominator by 11. So negative 5 is actually a negative 55 over 11, isn't it? Sure is. Trust me on this one. If you try that. So if I add 34 over 11 to both sides, I end up with y equals negative 55 and a positive 34, 5 and 3. So I got negative 21 over 11. So the answer is, or the solution is negative 17 over 11, and negative 21 over 11. Now, I would be happy to go through this with you individually. I just don't want to take up a lot of time on the video. I'm trying to keep the videos short. So I don't want to go through and put these in, but definitely take a few moments and plug it into the original equations and make sure it works. And meanwhile, I'm going to try one more here, and that is change colors one more time, and I have 2x minus 3y equals 1, and 5x plus 6y equals 16. Once again, the name of the game is eliminate. So I got negative 3y and a positive 6y. So why not multiply this first one by 2? What does that equal? 4x minus 6y equals 2. Under here we have 5x plus 6y equals 16. Now, do you understand why I chose 2 and why I decided to multiply this first equation by 2? Because I get me negative 6y. You look at your terms and you say, okay, how am I going to eliminate one of my terms? And that's what I did. And so here I've got 4 and 5 is 9x. These two cancel, equals 16, and 2 is 18. And folks, it just doesn't get any easier or prettier than this. X equals 2. 18 over 9 is 2. So if x equals 2, 2 times 2, I'm going to use the first one because it's easier, it's smaller numbers. I like things the easy way. 2 times 2 minus 3y equals 1. So 4 minus 3y equals 1. Subtract 4, negative 3y equals negative 3. Divide by negative 3, divide by negative 3, y equals 1. So my ordered pairs my ordered pair 2, 1, that's my solution. And real quickly I can throw these in and just do it in my head. 2 times 2 is 4, minus 3, that's 1. 2 times 5 is 10, plus 6 times 1 is 6, so that's 16. So they both work out, and this is definitely my solution. So thank you for listening. I will see you soon.